Hello class, for this video, let us have another example in designing a doubly reinforced beam. So for our second example, a reinforced concrete beam has a width of 300 millimeters and an effective depth of 600 millimeters. Compressive reinforcement, if required, will be placed at a depth or effective depth which is 60 millimeters from the top. FC prime natin is 27.5 MPa. And Fy natin is 415 megapascals. Use 2010 or the same lang yan sa 2015 na NSCP. The beam is to support a factored bending moment of 670 kilonewton meter. So first thing that we need to solve is to determine the area of steel required as tension reinforcement if the strain in the extreme tension steel is 0.004. Okay, so the first thing that we need to do is to draw the figure. So here we have our figure. Lagay lang po natin na yung width niya is 300 millimeters. Ayan. And then, binigyan din tayo ng effective depth, which is 600 millimeters. So for example, dyan na-locate yung center of gravity ng ating area ng steel na nasa ibaba. So that is our effective depth. Ayan. Okay, so lagyan lang natin ng example. Hindi natin alam kung ilang bars. So let us just assume na 3. Okay, so dito, ayan. So ang first thing na dapat nating hanapin daw is the area of steel required as tension reinforcement if the strain in the extreme tension steel is 0.004. No, inulit ko lang ng pagbasa. Yung gagawin natin dito or yung binigay kasi sa atin is yung ating epsilon which is 0.004. So therefore, hahanapin natin yung equivalent niya na phi, 'di ba? Because we need to interpolate this one in order for us to have our equivalent na phi for that kind of for that value of epsilon. So therefore, sa ating calculator, pwede natin gamitin yung mode 32. Yung Casio. Assuming na pwede pa yung na-calculator class, pero kung hindi na yun pwede, so therefore, you will be manually using your calculator in interpolation. Okay? So, let us assume na yung x, that yan yung epsilon natin, while our y is our phi. Okay? So, take note na nasa range ng 0.002 to 0.005 yung ating epsilon, yung strain, di ba? And then, pag 0.002 yung ating epsilon or strain, yung ating phi is 0.65. If 0.005 yung phi natin is 0.9. Okay? So, yung hinahanap natin is yung EY natin, which is binigay naman sa atin, which is 0.004. So, therefore, we need to find the value of its corresponding na phi. Okay? Okay, so let us use this calculator. Mode 3 for statistics, then 2 for a linear na interpolation. So 0.002, 0.005, and then pag 0.002, yung phi natin is 0.65. Tapos pag 0.005, 0.9 tayo. Ayan. So click mo lang yung AC, then shift statistics, hahanapin natin yung ating regression 5. Then yung y, yung ating hinahanap, no? Y hat, which is so 5 pa din. So therefore, yung ilalagay natin na value is 0.004. Ano yung corresponding niya na value ng phi? That is 0.8167. No? I-round up na lang natin to the nearest 4 decimal places. So, 0.8167 siya. Okay? Ayan, so balik tayo dito. Sulat natin yung 0.8167. 0.8167. Okay. So, next thing is, di ba, hahanapin natin yung area ng steel required. So, therefore, kukunin din natin si value ng C natin, yung small letter C, di ba? That C, your small letter C, that is your length from our topmost fiber papunta kung saan nag-zero yung ating strain, di ba? So what is the formula for that one? Sabi dito is, if the strain in the extreme tension still is 0.004. So lagay natin doon yung C natin na formula, yung nasa sa ating formulas, di ba? 0.003 multiplied by our D, or D total, di ba? Divided by yung ating 0.003 plus yung ating E na given, or for this type of question is EY. Okay. So therefore, lagay lang natin yung kanyang mga values. 'Di ba? So, lagay lang natin dito 0.003 times dt. Ayan. Divided by, so, next is 0.003 plus 0.004 because that is the value of our EY na binigay naman din sa atin. So, simplify lang natin to. C natin is equivalent to, using our calculator, that is 3/7 dt. So, magagamit natin yan mamaya. Okay? So, next thing that we need to do is to compute for our Rn. Diba? So, area ng steel required yung hinahanap natin. If our, no, paulit-ulit lang ako, extreme tension sa steel natin, or extreme tension sa steel is 0.04. So, Rn natin, binigay naman din, di ba, yung ating moment. So, that is Mu divided by, that is Mn, di ba? Mn over Pd squared. Pero para mas madali tayo, no, kasi factored bending moment na yung binigay, take note that Mu is equivalent to phi times Mn. So, yung formula natin, isulat na lang natin para hindi tayo malito. Mn over, that is Mn over Bd squared. So, palitan lang natin si Mn kasi Mu yung given natin, magiging Mu over phi Bd squared. Ayan. So, straight lang natin yung line. Ayan siya. So, dito, 670, ilagay lang natin yung Mu 670. Take note na Mu siya kasi factored na siya. Pag Mn, hindi pa yun siya factored. No? Nominal pa yun siya. Okay, so multiply natin ng 10 to the power of 6 para maging Newton millimeter siya. Then phi natin, which is na-solve natin kanina, which is 0.8167. Then base natin is given naman din siya, 300. Then yung ating depth, which is also given, which is equivalent to 600. Yan. So by using our calculator, we can compute our Rn, which is equivalent to 7.6. Yan siya. So, alam na natin yung process, di ba? Kasi right after you solve your Rn, you can use your, or you can solve for your raw na actual, or raw na required, di ba? So, yung formula natin, I hope that you can memorize that one kasi pabalik-balik lang tayo dito. 0.85 Fc prime divided by yung Fy. And then we have 1 minus the square root of 1 minus 2 Rn. Diba? Divided by 0.85 Fc prime. Ayan. So, ayan siya. Okay. So, next thing is substitution lang po. Rho up 0.85. Fc prime natin is given 27. 27.5. Fy natin is equivalent to 415. Then 1 minus square root of 1 minus 2 Rn na solve natin kanina, which is 7.6 divided by 0.85 Fc prime 415. Ayan. Extend lang natin. Close parenthesis. Okay, so by using our calculator, yung result nito is equivalent to 0.02302. Ayan, so nakalagay dito. That is the value of our raw actual. So therefore, solve natin yung ating raw maximum, di ba? So we must check if this is doubly or singly. So solve natin si raw maximum. If raw actual natin is greater than raw maximum, therefore our beam is a doubly reinforced beam. Therefore, kukunin natin yung ating itaas at sa baba na area natin. Okay? So proceed tayo to our next slide. Ayan po, so to continue, lagyan lang po natin dito ng compressive natin na steel. Then, lagyan natin ng D prime, which is equivalent to 60 millimeters. Ayan. So, kadagdagang information lang po. Okay? So, sabi ko kanina, di ba, that we need to solve our maximum na raw and we need to compare if mas greater than ba siya or mas lesser than. Okay? So, what is our raw maximum? Ilagay natin yung formula. Raw maximum sa ating doubly or sa ating sa doubly or singly man lang. No? Same lang yung kanyang formula. So, dito, raw maximum for our tension reinforcement. Diba? So, dalawa yun for compression and tension. So, 0.85 FC prime divided by Fy, then multiplied by beta 1 multiplied by 3/7. Ayan. So that is the formula for our raw maximum. Okay, so substitute lang po natin yung mga values. 0.85 FC prime natin is equivalent to 27.7. Sorry, 0.5 pala. Divided by Fy natin, which is 415. So take note yung ating beta. If ang value ng beta natin is equivalent to 0.85 if our FC prime is 28 megapascal or lower. So therefore, 27.5 is lower than 28. So automatically, 0.85 yung ating beta. Then 3/7. Okay, so by using our calculator, makukuha na natin yung ating raw maximum, which is equivalent to 0.02052. Ayan. So next thing is we need to compare that one. No? 2302, 2052. So islagay natin dito yung ating raw na actual. Then yung ating raw na maximum. No? Para ma-compare natin. Talaga, raw maximum natin is 0.02052 while our raw actual is equivalent to 2302. 0.02302. So as you can see, greater than po sa raw maximum natin yung raw actual. Therefore, hindi kakayanin na sa baba lang lahat ng reinforcement steel natin for tension side. So therefore, we can conclude that this is a doubly reinforced beam. No? So design natin as doubly reinforced beam. Okay? Sulat natin ulit. Design as doubly reinforced beam. Ayan. So, hindi pa tayo tapos. Hahanapin pa natin yung total area na kailangan natin kasi yan lang yung kailangan natin sa number 1. No? Area of the steel required as tension reinforcement. Okay? So, proceed tayo dito. Take note, di ba? AS1 natin is equivalent to our AS maximum. Di ba? Then, that is raw maximum natin multiplied by BD. So, ito lang yung limit na dapat mong ilagay sa ibaba. Okay? So, solve natin si AS1. Diba? So, ang goal natin, sige, mamaya na, no? Unahin muna natin to. So, AS max natin is equivalent to raw max natin is 0.02052. Then, base natin is 300. depth natin is 600. So by that, makukuha natin si AS1 which is equivalent to 3,693.6 millimeters square. So take note, yan lang yung maximum na kailangan dapat nating ilagay sa bottom, 'di ba? So therefore, kailangan pa natin yung reinforcement niya which is AS2. So therefore, paano ba kukunin si AS2? Ayan, AS2 yung kailangan natin kunin. So by getting our AS2, take note that, 'di ba? Yung sa figure natin, we have our sulat natin, 'di ba? We have here yung AS natin, then dito is yung AS prime. So 'di ba mahahati si AS into 2. Si AS1 plus dito is si AS2, 'di ba? So therefore this is moment 1, then this is moment 2. Okay? So, lahat ng moment na yan is Mn, di ba? Mn is equivalent to M1 plus M2. So, we will be using this equation in getting our AS2. Okay? So, I hope that you could recall that one. Meron tayong video kung paano siya na-derive. So, paki-review na lang nun. Yan. So, lagay natin. Mn natin is, nandun kanina, that is, sulat na lang natin. Mn is equivalent to M1 plus M2. Mn natin is in terms of Mu, kasi Mu yung given natin. Phi is equivalent to M1 natin. What is our M1? Diba? Yung tension natin, P natin, and then multiplied by our lever arm. So, M1 natin, nasa figure, which is AS1. Diba? Yung tension 1 natin. Lagyan natin na tension 1 and then yung tension 2 natin. So, AS1 Fy multiplied by our lever arm, which is D minus A over 2. Ayan. Diba? And then, yung ating M2, paki-review na lang class kung saan to galing, basta doon yun sa ating derivation of formula. T2 natin is AS2, diba? AS2 multiplied by Fy, then yung lever arm niya, diba? Which is D minus D prime. Okay? So with this equation, meron pa tayong kulang, which is yung A natin or yung height ng compression block natin. So don't worry about that, diba? Kayang-kaya natin yung kunin because the formula for A or our height of compression block is just beta multiplied by C. Diba? So kanina, diba? Nakuha natin na beta is 0.85 because our FC prime is less than 28 megapascal. Then kanina, again, nakuha natin yung value ng C natin which is 3/7 multiplied by our D total. Or yung D total natin is 600, no? Effective depth. No? Okay? So, hindi yan D total, sorry. So, effective depth, yung dalawa na, diba? Sa 2-layered or 1-layered. So, therefore, si D is the same lang kay DT if 1-layered lang tayo. So, that is 3/7 multiplied by 600. Ayan po. So, therefore, makukuha na natin the value of our A is equivalent to 218.57 millimeters. Ayan. So, continue tayo to our next slide. Since meron na tayong value ng ating A, so kaya na nating i-substitute lahat ng values sa ating equation kanina, which is this one. Ito. Para makuha natin yung ating AS2. Okay? So, substitute lang po tayo or substitution. So, therefore, lagay natin dito, dito na lang po, 670 times 10 to the power of 6 divided by yung ating rho, which is 0.8167, phi pala, hindi rho. Then, 3693, that is our AS1, 0.6 multiplied by our Fy, 415. Lever arm natin is equivalent to 600. Depth minus your tawag doon, A natin, 218.57 divided by 2. Okay? How about yung sa tension 2 natin o T2? That is AS2. Yan yung hinahanap natin. Multiplied by Fy. Then multiplied by its lever arm, which is 600 minus ito, 60. Okay, so by using the shift solve na function sa ating calculator or if hindi na siya pwede sa board exam, so you need to compute it manually. Basta ang result niyan is equivalent to 304.26 millimeters squared. Ayan po siya. So therefore, yung hinahanap natin sa number 1 is area of the steel required as tension reinforcement. So, lahat ng tension daw na kailangan natin sa beam. So, therefore, that is, natawag natin na AS or AS total. That is AS1 plus AS2. So, therefore, lapit na tayong matapos for situation number 1. Sulat lang natin. Plus 304.26. So, the total area na kailangan natin for our tension is 3,997.86 millimeters. Ayan, medyo mahaba siya, no? So, this is our final answer for our situation number 1. So, proceed tayo sa ating number 2 situation. Sabi dito, determine the area of steel required as tension reinforcement if the minimum strain in the extreme tension steel is limited to 0.005. So, kanina and ngayon is the same lang lahat ng process, but mas madali yung number 2 because we don't need to have an interpolation because yung 0.005 natin na epsilon, that is automatically, di ba? If our epsilon y natin is 0.005, that is automatic po na phi natin is 0.9. Ayan. Muntik na, no? Nakalimutan. Okay. So, pag ganyan, lahat ng process natin is the same. Ito yung mga phi yung ating change. Okay? Ayan. So, therefore, ang gagawin natin dito is kunin natin yung ating Romax na pa din, no? Let us start in getting or by getting our rho maximum. Kasi sabi dito, extreme tension steel, ayan, is 0.005. So, alam din natin pag 0.005 yung ating tawag dyan, strain ng steel, maximum din yung rho na gagamitin natin because this is our maximum na strain, 'di ba, na kailangan or na ma-withstand ng ating beam. So therefore, we will be using our rho max. Okay, so then yung clue natin. So proceed tayo. Rho maximum natin for tension is 0.85 0.85 FC prime divided by Fy. Ayan. Beta 1 multiplied by 3 over 8. Ayan po yung formula if maximum yung ating epsilon. Okay? Which is 0.005. So, substitute lang natin. Rho maximum is equivalent to 0.85. FC prime natin is equivalent to 27.5. And then Fy natin is 415. Beta natin is 0.85 kasi lesser than 28 yung ating FC prime multiplied by 3 over 8. Ayan. So, rho maximum natin is equivalent to 0.01795. So, therefore, that is our rho maximum. Okay? So, kukunin natin si AS1. Same pa din kanina. AS1 natin is rho maximum B times RD. So, 0.01795. Multiply natin yan by 300 and by 600. So, therefore, our AS1 is equivalent to 3,231 millimeter square. So we need to get our A muna class, which is the height of our compression block, that is beta multiplied by RC. So yung beta natin is 0.85, yung C natin is kukunin pa natin, di ba? So yung formula ng C natin is 0.003, then dt, di ba? Divided by 0.003 plus yung ating EY, which is yung EY natin, which is 0.005. Binigay naman din siya. So, therefore, ilalagay ko na lang dito. Ayan, para hindi kayo malito. 0.85 multiplied by 0.003 tt divided by yung ating 0.003 plus 0.004. So yung dt natin, no, lagay na lang natin yung value 600 because that is our effective depth. So therefore, makukuha natin si A, which is equivalent to 191.25 millimeters. Ayan. So since nakuha natin si A, therefore we can proceed yung ating moment, 'di ba? Yung same kanina, mu is equivalent to m1, sorry, that is not mu but mn, 'di ba? Mn is equivalent to m1 plus m2, or yung ating tension 1 plus yung ating lever arm, then tension 2 natin. So distance, lagay natin dito. No, yung kaniyang lever arm, length niya, then lever arm ng ating T2. Ayan. Okay, so Mn natin, same kanina, that is mu divided by phi. Then M1 natin, that is AS1 times Fy. Lever arm natin is depth minus A over 2. Then plus AS2 natin multiplied by Fy. Depth minus D prime. Ayan, walang over 2. Diba? So that is our formula in getting our AS2. Okay, so since meron na tayong A, substitute natin lahat, then we can have our AS2. Sa next slide natin, okay? Okay, continue tayo. Substitute na natin lahat ng values. 670 times 10 to the power of 6 divided by yung ating phi, which is 0.9. Ayan. Then yung area natin 1 is 3231 multiplied by 415, 600. Then yung A natin, di ba? Which is 191.25 divided by 2. Plus yung ating area ng AS2. Okay, lagay ko na lang sa ibaba. Ayan po. Plus area 2 natin is, yan yung hahanapin or hinahanap natin. Multiplied by 415, 600 minus 60. So by using our calculator, makukuha po natin si AS2, which is equivalent to 304.09 millimeter squared. So therefore, last step natin is total na tension steel na hinahanap, which is AS1 plus AS2. So kanina, nakuha natin si AS1, which is yung maximum sa ibaba, 3231. Plus AS2, 304.09. So therefore, our final answer for our situation number 2 is 3,535.09 millimeter squared. And that is our final answer. Ayan. Ayan po, so proceed tayo for our situation number 3. Sabi dito, determine the number of 28 millimeter diameter bars required as tension reinforcement if the reduction factor is 0.9. So ano daw yung number of bars natin sa ibaba if our reduction is 0.9. So luckily class, yung reduction factor natin na 0.9, ang katumbas niya na epsilon or strain, is equivalent to 0.005, which is yung na-solve natin kanina. So therefore, yung ating area ng steel na kailangan natin sa ibaba is equivalent sa answer natin kanina, which is 3535.09. So, ilagay natin dito. 3535.09 millimeter square. So, therefore, madali na lang po ito. Number of bars is equivalent to AS divided by yung ating area in our 1 bar. So, 3535.09 millimeter square. Huwag na natin magyan ng unit. Na divided by our area of bar. Sabi dito, ang gagamitin daw natin is 28. So, pi d squared over 4. So, pi 28 square over 4. Okay? So, by using our calculator, ang lalabas po dyan is 5.7 pieces. And then, take note, no? Round up natin into 6 pieces. Okay. Diba? Round up tayo. So, that is our final answer. For number or situation number 3. So, para mas maganda, ilagay natin yung 6 bars. Kasi sabi niya 6 bars. Ayan. So, therefore, we need 6 bars ng 28 millimeter na diameter sa tension natin na side, which is sa baba. So, for our situation number 4, sabi dito, if dalawang 28 millimeter diameter na compression steel will be added, determine the maximum tension reinforcement area that can be used for a tension-controlled section. Assume that the compression steel yields and neglect the effect of the displaced concrete. So for number 4, madali lang po ito kasi meron siyang formula. As you can recall, di ba, sa ating explanation, this is for our maximum na doubly reinforced beam, 'di ba? So lalagyan daw natin, no? So therefore, yung formula niya is rho maximum for our doubly reinforced beam is equivalent sa rho maximum ng singly reinforced beam natin plus AS2. 'Di ba? Divided by yung ating PD. So I hope that you could recall this formula. Na-discuss na natin to last time. So therefore, AS max ng ating DRB is equivalent to AS max natin sa ating SRB plus nung ating AS2. Ayan siya. AS2 na area. Okay? So therefore, with this one, substitution na tayo. So, AS maximum natin, which is na-solve natin kanina, di ba? So, that is 3231. That is our area ng maximum natin sa singly reinforced beam. And then, plus AS2 natin. So, sabi dito, ang AS2 daw natin, which is equivalent daw siya sa ating AS prime. 'Di ba? Kasi yung ano yung katumbas ng AS2 sa baba, yan din dong ilalagay natin na bakal sa itaas. So therefore, that is equivalent to dalawang pi. Ayan, lagyan natin, open close, pi 28 squared over 4. Ayan po. So therefore, AS maximum natin sa doubly reinforced beam is dinagdag lang natin yung nasa itaas natin na area. That is equivalent to 4,463 millimeter square. Ayan. So that is our final answer for number 4. Okay. So thank you for listening. I hope that you have learned something in this problem. Thank you and see you for our next video.